Hey guys, this is Yusa. In this video, we're going to talk about an additional question from the SP1. We're going to match the frequency response diagram with the zero pole diagram. So let's start from the first one. We could say that the 0 point is a real number and the pole point is equal to 1. So we could easily find the function, which is this one. So b less than 1, so apply e to j omega to z, we could get this one. When omega equal to 0, so this part will equal to 0, so the whole part will equal to 0. When omega equal to pi, so this part will equal to minus 1. So since b is less than 1, so the whole part will be bigger than 1. So according to that, we could find that this one, which is 0 when omega equal to 0, and pi equal to 1.2, which is bigger than 1 when the omega equal to pi. So next one, I'm going to talk about diagram 3. Since in this diagram we could say that we have two complex 0 points, which means we have resonant peaks, but this angle, which is the frequency, is quite lower, so the resonant peaks at a lower frequency, which is easily found, it matches with this one, because in all of the diagram with resonant peaks, these peaks happen at a lower frequency. So next one, I'm going to talk about diagram 4. In this one, we could say that the pole point is equal to minus 1, and the 0 point is equal to something that bigger than 1/2 but less than 1. So we could get this equation. Similarly, when omega equal to pi, we could get this part equal to pi, because this part will equal to minus 1, so this part equal to 0. So since this part only have one peak and equal to 0 when omega equal to pi, so we could easily find it matches with this one peak and equal to 0 when omega equal to pi. So next one, we're going to talk about diagram 7 and 8, because we could say that the difference between diagram 7 and diagram 8 is the distance between the pole 0 and between the pole point and 0 point. So we could get the function of diagram 7 and the diagram 8. So the pole equal to 0 and the 0 equal to something that's bigger than 1/2 but less than 1. And since it's easy to say that A is less than B, so when omega equal to 0, so this part will be 1 over 1 minus A. This part will be 1 over minus B. So this part is definitely lower than this part. So we could say that for the single peak diagram, since when omega equal to 0, both diagram will not equal to 0 at this point, which will bigger than almost bigger than 1, but so we locate our diagram to diagram 3 and diagram 8, but we could say that the distance between the pole and 0, which is So we know that when omega equal to 0, the frequency at omega equal to 0 is lower than the frequency of omega equal to 0 at diagram 8. So at the 0 point, this frequency is lower than this frequency. So this part will matches with diagram 7 and this part will match it with diagram 8. Next, we'll talk about diagram 6. In this diagram, we could easily find that we have two zeros and which are complex numbers. So we could get this function and apply e to j omega to this function. We could get at omega equal to 0, we could get that since this part will equal to 1, so this part will equal to 0, so the whole part will equal to 0. So we could find that since it has resonant peaks because of the complex 0 points and equal to 0 when omega equal to 0. So diagram 6 matches with this part. Now we're going to talk about diagram 2 and the diagram 5 because we could say that the difference between those diagrams is the distance between the pole 0 and between the pole and the 0. So we could easily get this function since it's two poles and the two complex 0. So we could say that the distance is basically longer than 1/2 but less than 1. So and the angle, which is the frequency, it's a little bit less than pi/2. So we could find likely frequency, which is 2 pi/5. So since we could find that in the diagram 2, 1c/1b, the absolute distance is bigger than 1c/1b in diagram 2, which means so at when omega equal to 0, the diagram 2 will have lower frequency, which means the diagram 2 matches with diagram 5 and diagram 5 which matches with diagram 1.